what we're going to learn today is how do you multiply two matrices together. So in your interactive notebook on page 7, you are going to put the title Multiplying Matrices. So here is the little lingo, and if you were in class, we would actually cut this out and put this into our interactive notebook, but we are not there. So you can write this in, multiplying matrices, to find the element in the nth row and the jth column of the product matrix, so product meaning the answer when we multiply, A times B, multiply each element of the row of A. So you take the first matrix, the row, by the corresponding element in the column of matrix. I should put the word of here, of B. Let's go back and put the word of here. So row of A by the corresponding element of the column of B. So that means here's my column. So I'm going to take the first row times the first column, and that gives me the position in my first row, first column. Now, how would I find another element? Well, let me switch colors here so you can see it. What if I want this position? Well, I would do the first row of A again times the second column of B. So that's first row, second column. That lands here. And then let's switch colors again. Let's do purple. So the second row of A times the first column of B gives me this position. And let's switch to a blue. And the bottom row of A times the second column of B gives me this position. So if you notice where these two would intersect, like if you meshed matrix A and matrix B together and the blues touched, they would touch in this lower position, which is the position that you're finding. So just remember, couple things. You can only multiply matrices if the number of columns in A is equal to the rows in B. So sometimes you can't even multiply them together. So the column of A has to match with the row of B. And we'll look at that on the next slide. But remember, RC, whenever you see a dimension, it's always rows, columns. So if you see a 2 by 3 matrix, remember the 2 represents how many rows you have, and the 3 represents how many columns. And if you think about an RC cola, that kind of helps you remember its rows and columns. So if I'm going to draw a 2 by 3 matrix, I've got 2 rows, 1, 2, by 3 columns, 1, 2, 3. So 3 columns and 2 rows, and it would look like this. And I'll just fill in 2 more numbers here, maybe 4 and 5. So that is a 2 row by 3 column matrix, just a reminder from the other day. Okay, so state whether the product is defined, and if it is, then give the dimensions of the product of AB, or we're also going to look at BA. Can we reverse them and multiply them? So let's take A times B. A is a 2 by 3 matrix. B is a 3 by 4 matrix. So the row by column, row by column. So that means the column of A has to match with the row of B. And these are both 3, so you can multiply these. So this one is a yes. We can multiply them together. Now, what dimensions do we get? Well, let's just draw it so you can see. If I have 1, 2 rows by 3 columns, you can put, like I said, any number in here. I'm just throwing some numbers to give an example, times, this time I'm doing a 3 by 4. 3 by 4 is going to look like this. 1, 2, 3 rows by 4 columns. So 3. I've got 1, 2, 3, 4 columns here. Can I multiply those together? Well, this row multiplies by this column, so it does match up. So the inner dimensions match, and guess what the answer is? The outer dimensions. So that means my answer is going to end up being a 2 by a 4 matrix. So what I like to do before I start a multiplication problem is go ahead and draw what my answer is going to look like. So I'll draw it where I have 2 rows by 4 columns, and that means I'm going to have 8 elements in my answer. So that's your first start. That's how to start the problem. That's how you decide if you can multiply them. Okay, now let's reverse it. Let's look at can I multiply B times A. So that means I would multiply 3 by 4 times a 2 by 3. Well, let's look. Do the inner dimensions match? The answer is no. I can't even multiply those together. So that one's just simply no. And so if you come across some of those, which you will, you say cannot be multiplied together, does not exist, DNE. Okay, so now let's look at the second example. I have A, which is a 3 by 2, and then B, which is a 3 by 3. And we want to see if we can multiply A times B. So A would be a 2 by 3 times B, which is a 3 by 3. Do the inner dimensions match? No. So can you do this one? No. What would you say? Well, that one doesn't exist or not possible. DNE means does not exist or not possible. What if I reverse B times A? Well, B is a 3 by 3 times A this time, which is a 3 by 2. Do my inner dimensions match? They do. That means I can multiply 3 rows times 3 columns. My resulting matrix is a 3 by 2. So there's your answer. It's a 3 by 2, and the second one is a yes. Okay, so what pattern do we see? We see that the inner dimensions must match. So inner, dimensions must match in order to multiply. There we go, and that's the pattern. Okay, so let's quiz ourselves real quick. Not a real quiz, just a practice quiz. We have 4 matrices. A is a 3 by 2. B is a 2 by 3. C is a 2 by 2. And D is a 3 by 3. Which of the following does not exist? So in other words, the inner dimensions do not match. We'll take a second. You can pause the video and check, but I'm just going to write them down. Okay, so I'm going to start with A. A is a 3 by 2 times a B, which is a 2 by 3. That's the order I'm given these in. My inner dimensions match, so that one works. Let's try A and C. So A is a 3 by 2. C is a 2 by 2. Do the inner dimensions match? That one's a yes. So far, the first 2 work. Let's try B and D. So B is a 2 by 3 times D, which is a 3 by 3. And again, the inner dimensions match. So this one works. And what would the answer be? The answer would be a 2 by 3. And then the last one is a 2 by 2. That's C times D, which is a 3 by 3. Now, both of those are square matrices, but the inner dimensions do not match. So that is the one that does not exist, a DNE or does not possible. So hopefully that kind of helped you check. Now let's practice actually multiplying these together. So let's go back a couple slides and look at this multiplication. So when we go to multiply, we're going to take the first row times the first column, but what do we do with those? Well, we take the first position A times the first position E and multiply those together, and then we're going to add to it the product of B and G, those multiplied together, and we add that and that gives us our first position. Then we take the first row times the second column, so I'm going to take A times F, and I'm going to multiply those together, and I'm going to add to it B and H, and that gives me this top row second column. We repeat it again. On the bottom, we take the bottom row first column, C times E, and then we're going to add to it G and D, and then finally we go to the last one, C times F and D times H, and add those together. Now, it seems very confusing at first, but once you get a couple down, you'll see. Okay, so I'm going to start first row, first column. Now, this is a 2 by 2 matrix, and I'm multiplying it by another 2 by 2. My inner dimensions do match, and my outer dimensions, the answer will be a 2 by 2. So let's go ahead and set up a 2 by 2 matrix. Now, I'm making mine very large so I can show my work. Okay, that's what we want you to do, show your work. I'm going to take this first position, -2 and -1, and I'm going to multiply those together. And I'm going to add to it 3 times -2. 3 times -2. And that's going to give me the term in the top left position. So that's going to give me +2 plus -6. So 2 plus -6 is -4. And that is the term or the element in the top left position. Now let's go to the second or top row again. Whoops. Top row, second column. Well, that's going to be over here, my top row, second column. So let's multiply -2 times +3 this time. And I'm going to add to it my +3 and my positive times my +4. So let's see, that's going to give me -6 plus 12. So -6, I'll just jot my work up here, plus 12. That's going to give me a +6. So that is my second element in my matrix. Now let's go to the next row, the second row here. So we're going to the bottom row. I go back to the first column to get this position. Now notice, if I have the second row, first column, that's this position, which is second row, but the first column. Let's multiply that together. So 1 times -1. We're going to add to it -4 times -2. And I'll just do my scratch work here. -1 plus 8. That's going to give me +7. Now there's a lot of room for arithmetic errors, so be very careful as you're multiplying and adding here. And for this last position, that is the bottom row and that is the second column. So I go bottom row, second column. And I'm going to multiply 1 times 3. And I'm going to add to it -4 times +4. And that's going to give me 3 plus -16, which is what, -13? And there is my solution. So let's box it up since that's our solution. There's our answer as we multiply the 2 by 2s together. So let's try one that's not square. Let's push ourselves a little bit and see if these will even multiply. Okay, this first one is 3 rows by 2 columns. we're going to multiply that by a 2 by 2. Well, we can see, yes, indeed, they do multiply. The inner dimensions match, but my outer dimensions give my solution. So my answer is actually going to be a 3 by 2. So when I go to set this up, I'm going to make sure I leave room because I'm going to have 3 rows and 2 columns. So it's going to be longer and skinnier. It's going to be long and skinny because I'm going to have 3. Okay, so now let's highlight and work through this one. Erase that up. Okay, so I'm going to take this row times this column. So I have -3 times 1. My first times my first, then I take my second times my second. So plus 3, -2. Okay, I'm going to go down and go ahead and get my answer. So my answer is going to be -3 plus -6, which is -9. Okay, let's work through the second. Whoops, I shouldn't erase that first one because I'm still first row, but now I'm second column. And I have 3, or -3, times 0 plus 3 times -1. So I'm taking this row times this column. And that's going to give me 0 plus -3. So that's just a -3. So I have my first row done. Now let's go to the second row. Second row, first column. That's going to give me 3 times 1 plus second elements, -2 times -2. So that's going to give me 3 plus +4. That's 7. And then I'm going to take the 3, -2 times my second column. So that's +3 times 0 plus second row, second column, -2 times -1. So that's 0 plus 2. That's just a 2. Okay, now let's go to the last one. Let me erase in here so you can see the third one. Let's do this one in red. So now I'm going bottom row, first column, 0 times 1. Well, that's just going to be 0 plus -1 times -2. And that's going to give me +2. And then the bottom row, second column, 0 times 0 is 0 plus -1 times -1 will give me +1. So this is my solution. Let me box it up so we can show it. There's my solution when I multiply these two matrices together, a 3 by 2 times a 2 by 2. And my answer is a 3 by 2. Again, check those dimensions. Okay, now this is a whopper. We need to look at this one carefully. What are the dimensions? This one is 3 rows by 3 columns. This one is also 3 rows by 3 columns. So I have a 3 by 3 times a 3 by 3. My inner dimensions indeed match. My outer dimensions are a 3 by 3. So that means when I multiply a square, I'm going to get a square, and it's going to be the same size. So this one's going to be a huge 3 by 3 matrix. Okay, so let's take this row times this column. Now that I'm doing these and I don't have as much room, I don't know that I'm going to show each multiplication. I'll probably just show the product. So I'm going to take 2 times 10, which is 20. Now I'm going to add to it 8 times -1, which is -8, plus, yes, a third one, -3 times +3, which is -9. Okay, so that means my very first top left position will be 20 minus 8 is 12. 12 minus 9 is 3. So that's just positive 3. Okay, let's do the first row, second column. That's going to be 2 times 9, which is 18, plus 8 times 5, which is 40, plus negative 3 times 7 is negative 21. And you can grab a calculator if you want. Let's see, that's going to give me 58 minus 21 is going to be, what, 37? So that's going to be the second position. Ooh, this gets long, doesn't it? Okay, now let's take this third row. This third row, I'm probably not going to have enough room, but I just want to show you. I'm going to squeeze it in right here. That's going to be first row, first column, or third column is negative 4 plus, I'm going to take my 8 times my 8, 64. Yes, they can get big. Negative 3 times 0. Well, that's kind of nice. I got a 0 there. So that's going to give me a positive 60 when I add those together. Whew, so it took that long to do my first row times my column. So these 3 by 3s get a little harder. Okay, let's go down. I'm going to erase a little bit, get rid of some of this stuff. And I'm going to work on the second row. Second row, first column. So I've got a 50, a negative 6, and a 12. And I'm adding these together. So that's 50 minus 6 is 44. 44, 54, 55, 56. 56 is my first one. Then let's take first row, second column. So that's 9 times 5 is 45, plus 6 times 5 is 30, plus 4 times 7 is 27. Okay, so that's 75, 85, 95, 102. So that position is 102. And then row times the last column. I've got negative 8. Sorry, that's not negative 8. Make a little more room here. That's going to give me negative 10. Where did I get that? 5 times negative 2. Second one, 6 times 8, 48. And then 4 times 0, that's kind of nice, that's 0. So when I add those together, I'm going to get a positive 38. Okay, and then the last row times each of my columns. Hopefully you're getting the hang of it by now. So we've got a negative 10 plus a 0 plus a 21. So that gives me bottom left row, that's our left column, bottom left column is going to give me 11. Let's go back up. This row times this column, that's going to give me negative 9 plus 0 plus 49. So that's just 40. So that's the center one. And then the bottom row times the final column. That's going to give us what? Positive 2 plus 0 plus 0. Oh, that was nice. Whoever wrote this problem thought about us. We're getting tired by the end. And there's our 2. Okay, so I'm going to box up our answer to this 3 by 3. It's 3, 37, 60, 56, 102, 38, 11, 40, and 2. Hopefully I didn't make any arithmetic errors. If I did, y'all can correct me.